Namaste and welcome to the AI Guru video channel. My name is Tristan. I work as a deep learning trainer, mentor, engineer, and consultant. My mission is to help as many people as possible to apply artificial intelligence. This has never been as easy as today. We live in excellent times. The knowledge of the world is available to everyone, and I help you to get started in no time. Trust me, AI is 1% theory and 99% practice. Do you want to join my mission? Feel free to support me on Patreon, subscribe to my YouTube channel, connect with me on Facebook, add me on LinkedIn, and read my blog. You will find all links in the description below. Thanks and enjoy the video. Did you know that you can do deep learning in less than 20 lines of code? I will show you. I assume that you have already installed Python and TensorFlow. Let's get started. The first thing you would love to do is making TensorFlow available in your project. Next, data. No data means no deep learning. Fortunately, TensorFlow comes pre-packed with a couple of datasets. MNIST is one of them, and it is all about handwritten number recognition. You feed a picture of a number into your network, and it tells you which number it actually is. Let us load the data in the memory. In deep learning, you will always have at least two sets of data. The training set is used to optimize your neural network. The testing set, on the other hand, is only used after training to evaluate how good your neural network really is. I always say that neural nets are spoiled little kids when it comes to data. They tend to prefer small numbers. That is why we normalize all input data by dividing by 255. This already concludes the data part. Now comes the network architecture. We create a sequential model that consists of layers that are stacked on top of each other. Our first layer is flatten. It takes our 2D image data and transforms it into 1D data without losing any information. Our second layer is dense. It is a fully connected layer. It is the most basic layer of all. It is fairly old and very effective. 512 is our number of hidden units. The activation function is a rectified linear unit. Our third layer is dropout. This layer randomly resets connections during training, one of the many ways to fight overfitting. Our final layer is another dense. We have 10 output units because we are going to identify 10 different digits. And we use softmax as our activation function because we have a classifier with more than 2 classes. Compiling comes after architecture design. We add the Adam optimizer. Optimizers are the training algorithms that fit your neural network to your data. We also add categorical cross-entropy, which during training measures how big the error of your network is. And we add accuracy as a metric to monitor how many predictions are right. Now we fit the neural network on our data. We train on input data and corresponding output for 5 epochs. And finally, we evaluate our net on the test data, because we want to know how well the model works on previously unseen data. Let's run our script. This might take a while, but usually you are expected to be quite patient when it comes to training. Some trainings might even take a couple of days. Et voilà! Around 98% accuracy on our training data, and a similar number on our test data. That was deep learning in less than 20 lines of code. Namaste!